And then we can regulate our cooling capacity after that. Now I can show you indirect cooling.
Ah, yes.
So we have quite the same loop here,
Yes.
but here we have this heat exchanger is not cooling then the hydrogen, it's cooling a coolant, like a brine or water glycol. Then we have some pumps here and valves and storage, so that this coolant is stored, and this heat exchanger is then inside the dispenser again.
Okay, understood.
So there is also a boundary here and piping on site.
And so this is a coolant. What would be the coolant here? And you said here we have brine or something like
here's
that?
a liquid, medium.
Okay.
Yeah, and it stays always liquid.
It stays always, okay.
Yeah, and here is the refrigerant.
Yes.
That is in one phase gaseous and in the other phase.
Okay, well, what types of refrigerants do you use there?
We focus on CO2 as a refrigerant.
As a refrigerant. Okay, okay.
Because it's very eco-friendly.
Ah, okay, all right. Okay, that's obviously very important. You know, as we're trying to make this part of a sustainable cycle. So, how do you regulate the system? You know, I know that with temperature and so on, this can sometimes be a challenge.
Yeah.
How do you? Does the hydrogen always come at the same temperature from the storage, or is there a faster or slower flow? How does that work?
Yeah, as you said, there is the mass flow is very fluctuating.
Yes.
So there is a high flow at the beginning, and then it's decreasing a little bit.
Yeah.
And also the temperature is not constant. It depends on the ambient temperature and also on the type of the station. So how many pressure banks are available and so on.
Yes.
And also at which pressure the car is coming.
Okay.
If the starting pressure is higher or lower.
Do you actually know what pressure is or what temperature is in the car?
No, we don't receive this info.
Ah, okay.
And then we can regulate our cooling capacity. After that. So we can control the expansion valve.
Yes.
Then the speed of the compressor. And we also have an hot gas bypass, so we can regulate our cooling capacity from 0 to 100%.
Okay, so just looking at this diagram, so if you want to cool more, what do? You spin up the compressor.
Maybe I can show it better at this one.
Yeah.
If you need more cooling capacity, you run the compressor at higher frequency, so more refrigerant is pumped through the system, and more mass flow means more cooling capacity.
Okay, so you have a lower pressure here and then higher pressure on that side. Okay. And do you do anything with the expansion valve? Do you regulate that as well?
Yeah, we regulate also this expansion valve. This expansion valve is controlling the mass flow through the heat exchanger.
Okay.
So if there is less cooling capacity needed, the mass flow is also reduced for the expansion valve.
Okay. All right. Okay. And just you mentioned in the other one. Sorry for jumping a little bit, but you mentioned the other one that you're using brine, and in this cycle you would use CO2, and then so the where would the CO2 be liquid and where would it be gaseous? Again, can you just help us?
It's getting liquid after the condenser.
Okay. So it comes out gaseous here at a high pressure.
High temperature. Yeah.
Okay, and then gets liquefied in there. Okay. And then it's coming out liquefied at ambient temperature?
Nearly ambient, higher.
Okay.
So normally 7 K.
But that must be then high pressure.
Still
very
high pressure.
Very high pressure, because CO2 at ambient, to get that into liquid, what kind of pressures are we talking about there?
It's up to 100 bar.
Okay. All right. Okay. And then comes that through there, and then as it expands, it then gets into gaseous state again.
Yeah.
Okay.